Well, since the camera is already situated this way, it seems to make sense to do my next video this way. So with the math videos, I tend to go this way. This is not really a math video, but hey, it will kind of help. So we're talking about right now a couple of different terms. So this is video 6. And we have a couple of new terms that need to come up. So the first one is this idea of vectors versus scalars. Now, I am not going to write down both definitions because number one, I believe they're in your text. Two, I want you to learn how to listen and hear a definition. But a vector is a quantity that's fully described by both magnitude and direction. So it's a number that has both magnitude and direction, how big it is and which way it's going. A scalar, on the other hand, only has how big it is. So if I'm saying I drove 60 miles per hour north, that's a vector. If I say that I drive 60 miles per hour north, okay, that is a vector versus 60 miles per hour. That's a scalar. Both of these have magnitude, which is the number part. But this is direction. Now, it's important to understand that because if you think about a number line, if you switch directions, your direction switches, your sign switches. So that's why that's important. So vectors are very conscious of the direction that you're going in. So with that in mind, we have two new terms. Well, one's a little bit of an old term, but they relate. How we use them is different. So new terms, we have displacement and we have distance. Displacement versus distance. Distance is the total amount of change of location that something has. That's distance. Displacement is how you compare to where you started. So let's say I decide to walk 2 miles this way, so to the east, 4 miles south, 2 miles to the west, and 4 miles north. I've effectively walked in a circle. Well, actually a square. My distance would be the 2 plus the 4 plus the 2 plus the 4. So my distance in this case is 12 miles. My displacement is 0. Because compared to where I started, I didn't go anywhere. A good example of this is when your mom leaves and you're sitting there watching TV and she goes to work maybe on a Saturday and she comes back, and when she comes back you're still sitting in the same spot and she thinks you've done nothing for the whole day, when in fact you did some homework, you went and saw some friends, you put up the dishes, you helped your little sister with her homework, and then you went back to the couch. It looks as if you've done nothing because your displacement is 0, when in fact you've accomplished quite a bit. So another vector quantity that we need to bring up is velocity. Now, in conversation, we tend to use velocity and speed as the same, but they're not the same because velocity takes into account the direction that you're going in. So you can actually have a negative velocity if you're going in a negative direction, and negative is usually determined by the problem. So let's say if I decide that north is the positive direction and you go south, then that would be negative. So in other words, this is kind of a positive displacement. This would be a negative displacement. This is a positive displacement. This is a negative displacement. So our velocity can actually be positive or negative as well, because velocity is displacement over time, and speed is distance over time. So earlier when I talked about going 60 miles per hour north, if I'm driving 60 miles per hour to the north, that might be considered a positive velocity. I could just say positive 60 miles per hour. And it's understood that that means north. But on the other hand, if I was driving negative 60 miles per hour, that's considered south. All right, I think that's it for all of our terminology. We have one more video.